The next topic is Hall effect. Have you heard about this Hall effect before? Hall effect. So there is a definition for Hall effect. When a current carrying conductor or a semiconductor, okay, is placed in a transverse magnetic field. So this is the current direction. So if this act in the x direction, okay, x, y, and z, and it is placed in a magnetic field. The magnetic field act in the z direction. It's B. Magnetic field is mentioned as B. So current I. Now what happens means a potential difference is generated inside the conductor or semiconductor material. There will be some potential difference will take place. So a potential, due to the potential difference, a voltage will be arise there. Okay, it is formed inside the material, and that voltage generated is mutually perpendicular to the current and magnetic field direction. அப்போ இது எந்த டைரக்ஷன்ல இருக்கும்? Y டைரக்ஷன்ல இருக்கும். ஓகேவா? This is in current is in X direction and B is in Z direction. Therefore, the voltage or the field E, it is said to be Hall field, and the voltage generated is mentioned as Hall voltage. Okay. So write down the definition. When a current carrying conductor or semiconductor is placed in a transverse, it means perpendicular, transverse magnetic field B, a potential difference is formed and the voltage is generated inside the mutually perpendicular to the current and magnetic field. So here this effect is called as Hall effect, and the voltage generated is called as Hall voltage. Okay, finally you can write. After writing this, write this sentence also. This effect is called as Hall effect, and the voltage generated is Hall voltage. So the importance of this Hall effect, so there is a experimental setup can be made with the help of this. It is used to find the type of semiconductor, whether it is a N-type semiconductor or P-type semiconductor. Okay, I'll teach you about that also. Have you finished, students? So at the end you write, this is called as Hall effect, and the voltage generated is called as Hall voltage. Shall I switch to the next? Hmm? Next subheading, Hall coefficient in an N-type semiconductor. So the similar kind of diagram you have to draw. Which may be a semiconductor or a conductor. So this is current in x direction, so Ix, and here the magnetic field in the z direction, and the voltage generated inside, that can be measured with the help of a voltmeter. So you know, for a N-type semiconductor, the majority charge carries another electrons. So இது ஒரு ஃபேஸ்னு வச்சுக்கோங்க, மேலே இருக்கிறது இது ஒரு ஃபேஸ், இது ஒரு ஃபேஸ். ஃபேஸ்னா இந்த ஃபேஸி. Okay, if this is first above phase and bottom phase. So more electrons are there. Let me draw it here. So electrons are present both in the top and bottom. When the magnetic field is acting on it, what happens means it tries to, because it affects the electrons in the phase. This is phase 1 and this is phase 2, or vice versa, I can use anything. So the electron at the top, it bends downward and accumulate in the bottom. Not all the electrons, some electrons will be bent down and it comes to the down phase. Okay, that means to the phase 2. So there is a potential difference will takes place between phase 1 and phase 2. Okay va, so charges on the distribution on the different இருந்துச்சுனா அங்க கண்டிப்பா என்ன இருக்கும், potential difference. So when there is a potential difference, what will be formed there? The voltage will be right, that means the field is generated. Okay, that's how it will happen. Okay, so here, due to the potential difference, a force is acting on the electron, and also the magnetic field, due to the magnetic field also one force is acting on it. So two forces are acting on the electron. Okay, so with this we are going to find the Hall coefficient. I will tell you about that. First you draw this diagram. Once finished, we can move to the next. So two forces acting. First one is the force due to potential difference. Okay. So it is given by minus E into EH. The negative sign is for representing the negative charge of the electron, and EH is the Hall field. Then force due to the magnetic field. It is given by minus B E into V. B is the magnetic field, and E is the charge of the electron, and V is the velocity of the electron. This is equation number 2. So at equilibrium condition, these two equations are same. Okay, so at equilibrium, the force due to the potential difference is equal to the force due to the magnetic field. So equation 1 is equal to equation 2. So both side we have the minus, both will get cancelled. So minus EEH is equal to minus BEV. So this one, this will get cancelled. So EH is equal to B into V. EH is equal to B into V. Put this as equation number 3. Okay, so there is an expression to express this current density. So you know current density it is mentioned in terms of area, current per current flow per unit area அந்த மாதிரி வரும். இன்னொன்று இருக்கு with respect to the drift velocity. Okay, so that is given by the current density. So this the current is moving only in the x direction, so we can make it as Jx is equal to minus N E. Ne means the density of the electrons multiplied by the charge of the electron into the velocity. Okay, I think you have heard that J is equal to NeVd. Okay, so here it is Jx is equal to minus Ne into E into V. Right? From this you can write this V is equal to minus Jx by Ne into E. So we got the value for V. Now substitute this equation 4 in 3. Substitute equation 4 in 3. So what will you get? EH is equal to minus B into Jx by Ne into E. So the Hall field it is given by EH is equal to minus B into Jx by Ne into E. So the next step is EH is equal to Bjx into RH. This RH is the Hall coefficient. RH is the Hall coefficient. So RH is equal to minus 1 by NE into E. So this is the important thing you have to note down. RH, if the RH is equal to negative, then you can come to a conclusion that it is a N-type semiconductor. So similar thing can be done for the P-type semiconductor also. So easily you can do. Instead of Ne, you have to put Nh there. The other things are same. There it is positive, so no need to put the negative sign there. Actually, அதையும் வந்து நீங்கள் வந்து மென்ஷன் பண்ணிடலாம். இப்போ இங்கே வந்து 4, this is 5. Sorry, this one is 5 and this one is 6. Could you do for the P-type semiconductor? So in P-type semiconductor, you have the holes as majority charge carriers. So the same thing will happen there. There also the potential difference occur. All voltage will happen. The force is due to the potential difference will be there, and force due to the magnetic field is also there. But in the sign there is a difference. Okay, let us do that. Have you copied up to this? Okay, so next we can write Hall coefficient of a P-type semiconductor. So there is a experimental setup for this to find whether the given material is a N-type or P-type semiconductor அப்படிங்கறத நம்ம கண்டுபிடிக்கலாம். ஓகேவா? ஸோ அதுக்கு வந்து ஒரு எக்ஸ்பெரிமெண்ட் செட்டப்பாகவே இருக்கும். அதில் வச்சுட்டு from the voltage generated we can find. Okay. So for this, the same diagram with small differences. Again, the current in the x direction and magnetic field in the z direction, and the voltage generated, that is in the y direction. So here the bottom one is mentioned as positive and this is negative. So this is the voltmeter. So the voltage generated is Vh. The field is mentioned as Eh. Similar to that. Here, instead of having electrons, we have holes. So here also, due to the magnetic field, this holes bends down and comes to the bottom face. So if this is phase 1 and this is phase 2. So a potential difference will be generated and that is called as Hall voltage, and the field is called as Hall field. Now could you follow the same procedure to find the Hall coefficient of P-type semiconductor? What will be the first one? So force is acting, the same thing is happening here also. So the first one is force due to potential difference. So here we are considering it as a positive charge, so just E into EH. EH is the Hall field. And what about the other force due to the magnetic field? It's of course B into E into V. No negative sign. So if this is 1 and this is 2. And the same thing you have to follow and find. Tell me what is the value. In Jx, that is for after writing at equilibrium condition, both these are two equal, then equation 1 is equal to equation 2. Then applying that current density, அங்க வரும்போது நம்ம லாஸ்ட்ல என்ன பார்த்தோம், மைனஸ் NE into E into V ன்னு பார்த்தோமா. இங்க வந்து நமக்கு டென்சிட்டி ஆஃப் என்னது, holes. So minus NH into E into V. ஓகேவா? ஓகே. Do the same. அது previous மாதிரி அப்படியே பண்ணுங்க. Can easily do that. Okay. So at equilibrium, equation 1 is equal to equation 2, which means the force due to the potential difference is equal to the force due to the magnetic field. So EEH is equal to BEV. So E and E will get cancelled. EH is equal to BV. Put this as 3. Now Jx is equal to NH into E into V. So from this, if you want to write V, then it is equal to Jx by NH into E. So this V value can be substituted in equation 3 and you will get, so substitute 4 in 3, you will get EH is equal to B into Jx by NH into E. And tell me students, what will be the next step? EH is equal to B into Jx into RH. Okay. So here this RH, this call coefficient is RH is equal to 1 by NH into E. Okay. So that is the difference between the N-type and the P-type semiconductor. Finish? Okay. Next title is determination of Hall voltage. Determination of Hall voltage, which is mentioned as VH. So generally voltage can be mentioned as, here VH is equal to EH into T. E is the Hall field and T is the thickness of the sample. Already you know the value for EH. What is EH? As in general, EH is equal to B into RH into T, right? So here you have Jx. There is a relation for Jx with respect to the area of the conductor or the material which we are using. Okay. So current flowing per unit area of cross section, right? So here this Jx can be written as Jx is equal to Ix by A. Here the area is given by the breadth into the thickness of the sample or the width into the thickness of the sample. Okay. So that is the cross section. So if you have a material like this, okay, and this is the breadth and this is the thickness. Okay, wherever you are having a cross section, you will get a rectangle like this. So the breadth into this thickness, you will get the area of cross section. So Ix by A, which can be written as Ix by B into T. Okay, so B into T. This one you can substitute here. So VH is equal to, or you can give some equation number here. 1, 2. So substituting this, so equation 2 becomes VH is equal to B into Ix RH into T by B into T. So T and T will get cancelled, both representing the thickness. Doubt on that. So here, if you want to find this RH from this, okay, from this experimental பண்ணும்போது இப்படி தான் பண்ணணும். இதுல இருந்து RH கண்டுபிடிக்கணும்னு வைங்களேன். You have to just rearrange the equation. So RH is equal to VH into B by Ix into B. So by knowing these values, Hall voltage, okay, voltage generated in the voltmeter, okay, then the breadth, that is a known value. Then the current flow, what is the current passed through that? By using ammeter you can find that. And what is the magnetic field passed through that? That also you can find. Okay, these are known values. By knowing these values you can find the RH. So from this, if the RH is negative, then you can come to a conclusion it is a N-type semiconductor. If it is positive, then okay, that's all. So determination of Hall voltage, this is how you can determine that. Hall voltage, this equation, then Hall coefficient means this one. Just rearranging, you will get that. Okay, so what are the applications of this Hall effect? You want to சொல்லுங்க. என்ன கண்டுபிடிக்கலாம்? You can find the type of semiconductor, whether it is N-type or P-type, and here also you can find the mobility of the charge, mobility கண்டுபிடிக்கலாம், and the sign of the charge. So எல்லாமே அது ரிலேட்டடாக தான் வரும். And with this you can use this for a sensor. இதே வச்சு சென்சருக்கு வந்து யூஸ் பண்ணலாம். ஓகே, ஹால் எஃபெக்டை யூஸ் பண்ணி ஆக்ட் ஆகக்கூடிய சென்சர்ஸ் வந்து இருக்கு. ஓகே, ஸோ if there is an unknown magnetic field is there, so accordingly how the voltage is generated. From that you can find how much amount of, uh, by reverse calculation you can find the magnetic field. Okay, and the current also. So இந்த மாதிரி வந்து magnetic field base பண்ணி இருக்கக்கூடிய சென்சர்ல you can use this Hall effect, right? So you can write the points one by one. The applications of Hall effect. First point, it is used to determine the type of semiconductor. Next point, it gives the sign of the charge in the semiconductor. It gives information about the mobility of charge. It is used to measure the change in magnetic field. One minute.